Okay, good evening. Good evening, everyone. Yesterday, we observed how to perform finite link signal convolution in discrete case. Of course, convolution, deconvolution, or periodic convolution, we followed unique procedure, that is sum by column method. Sum by column method. That is an easy technique we have. Let us make the next observation. Properties of LTI system. Any LTI system means it is always represented with impulse response h of t or h of n. So when we can say an LTI system is causal, when we can say an LTI system is stable, static or memoryless, and the other condition, invertibility. Total 6 forms of systems we have learned, but now we are dealing the same concepts for an LTI system. What is the difference between introduction chapter and today's discussion is, in introduction we related two external signals, input and output. They are external signals. Input and output means they are external signal. Now we are using the word impulse response, means the black box behavior itself. We are using the word impulse response means we are checking internal behavior of the system. So general input output conditions are different. LTI system conditions are different. We should not mix them. How we learn general causality? Present output should depend on present input and past inputs. It may be past outputs also. Present output should depend on present input, past output. But here that condition changes to impulse response must be 0 for negative time. Impulse response must be 0 for negative time. H of t 0 for a t less than 0. How we are saying that condition impulse response must be 0 for negative time means, whenever we apply input as impulse, whatever the respective output we are getting, that is called as impulse response. Before application of the input as impulse at 0, we cannot get the output as impulse response. Before applying the input, output is not possible. Before applying the input, output is not possible. We are applying input as impulse at t equals to 0. What is the name of the output? Impulse response. When you are applying the input at 0, how we can expect the output before that instant? How we can expect the output before that instant? So before application of input, output is not possible. Before application of input, output is not possible. As we are applying input as impulse, impulse response must be 0 for negative time. What is stability? There we studied bounded input, bounded output. Here it changes to absolute area, integral mod h tau d tau less than infinity, sigma mod hn less than infinity. Here it changes to absolute area. How we got this condition? What is a convolution integral formula? We know, sir. Integral x of t minus tau h tau d tau. Apply the concept of stability to this relation. BIBO. Apply the concept of stability to this equation. We are dealing boundedness with respect to absolute value. We are dealing boundedness with respect to absolute value. Take modulus both sides. So right side one quantity mod x of t minus tau, another quantity mod h of tau d tau. One quantity mod x of t minus tau, another quantity mod h of tau. As we are saying the word bounded input, even we shift the signal, its magnitude is finite. To give an example, sir, u of t is a bounded input for which amplitude 1. U of t minus 4 also amplitude is 1 only. Even we delay the signal, it is not affecting amplitude. So once we feel mod xt is finite, means mod x of t minus 2 is also finite. So some finite quantity into this is the integral we are left with. What is our target here, sir? Mod yt must be finite. For making bounded output, compulsory this integral must be finite. For making bounded output, compulsory this integral must be finite. That is what this condition. An LTI system is stable if the impulse response is absolutely integrable or absolutely summable. Everyone go through it. An LTI system is stable if the impulse response is absolutely integrable or absolutely summable. Modulus, don't forget that modulus. An LTI system is stable if the impulse response is absolutely integrable or absolutely summable. LTI system means we are checking the internal behavior, the system behavior itself. Xt, yt, xn, yn means external signal behavior. Don't mix them. What is the definition of static system we studied, sir, earlier? If the input and output are observed at the same instant, that is called as a static system. If the input and output are observed at the same instant. Suppose if I have taken y of t equals to 5 into xt, if I have taken y of t equals to 5 into xt, 100% it is static system because input and output are observed at the same instant. So how to take impulse response definition here, sir? Input is impulse, output is impulse response. Xt is del t, y of t is h of t. If the input is impulse, output is impulse response. So h of t equals to k times del t, or ht 0 for t not equals to 0. Whenever the impulse response is just an impulse, whenever the impulse response is just an impulse, we can say the respective LTI system is static. Input impulse, output impulse response, this is also looking like static system. So when an LTI system is static means whenever the impulse response is simply an impulse, then the LTI system is static. How we learn the last conditions are invertibility concept. Different input signal should produce as different outputs. Different input signal should produce as different outputs. How that condition changes now? Observe here first. How that condition changes now? We are taking the system as h of t. Opposite to that block is h inverse of t. Input xt, output also. We want x of t, sir. So what is the output of first block? xt convolved ht. But what is the output of second block, sir? xt convolved ht convolved h inverse of t. This entire answer must be equals to xt means this entire answer must be equals to xt means it can be adjusted as xt convolved del t. So what is the conclusion? ht convolved h inverse of t is del of t. Listen one more time, sir. Our system is LTA h of t. This is inverse block. Output of first block is xt convolved ht. That is acting like input to second block. What is the output of second block, sir? xt convolved ht convolved h inverse t. This answer must be equals to xt means what is the conclusion we can make? ht convolved h inverse of t is del of t. That point you have to note down in the table. ht convolved h inverse of t is del of t. Discrete case. hn convolved h inverse of n is del of n. Whenever the word impulse response is used, then we have to use the stable characteristics. Whenever the word impulse response is used, then we are using the table characteristics. Yes, Rohan, correct. So this way we observed that condition, last condition, sir. ht convolved h inverse of t equals to del t. Please take a snapshot of this table, everyone. We are observing some models related to this, sir. Please take a snapshot. Is it so? Pawan, what we learned under invertibility? Just recollect. Once the system is invertible, then only we can find the inverse. You should take xt, we should recover back xt. That is the reason output of second system must be equals to xt. But instead of general system, now we are checking that for LTA. So what is the conclusion? xt convolved, ht convolved h inverse of t is del t. What then? Is it okay now? Volume still it is fluctuating. Okay. Generally, some funny questions will be asked on the table, sir. So everyone respond. If the impulse response is given by this expression, is it causal or non-causal, stable or unstable? Respond in the chat box. Impulse response is given as e power minus 3t u of t plus 4. Is it causal or non-causal, stable or unstable? It extends from minus 4 to infinity. Both positive and negative time it covers means non-causal. Stability, what is the condition we derived, sir? Absolute area. Here integral varies from minus 4 to infinity. E power minus 3 to. Definitely the integral is finite. It is a finite quantity, so system is stable. Non-causal and stable. Now you respond for discrete system. Minus 1 whole power n u of n minus 2. Think and respond. Minus 1 whole power n u of n minus 2. Same characteristics I want. Because of u of n minus 2, it covers positive samples, so causal. It is unstable. Mod Hn is our condition, don't forget. Don't feel plus 1 minus 1 amplitude levels. Sigma mod Hn. 1 added infinite times, answer is infinity, unstable. There is much difference between normal area and absolute area, sir. Don't have a wrong thought, plus or minus 1 amplitude level, they will cancel each other. It is not sigma Hn, sigma mod Hn. Negative amplitude also becomes positive. We are looking here for absolute area, not a normal area. Absolute area. Okay, wait for a while. Okay. Everyone think of this model, sir. Some discrete impulse response is given. A power n for positive index, B power n for negative index. To maintain stability, what is the condition on AB? To maintain stability, what is the condition on A and B? We know discrete form of stability means sigma mod Hn must be finite, sir. So think of an answer. For negative index, it is given as b power n, n less than 0, b power n, sir. Positive index, it is given as a power n. Second one is a standard summation formula, 1 plus a square, etc. First term by 1 minus common ratio. Common ratio must be less than 1. That is a standard formula. Because n covers negative index in the first summation, b must be opposite. B must be opposite. Otherwise, you do one thing. Take a specific number and try, sir. Assume a value like 1 by 2, b value like 3. Then you will know. Mod a less than 1, mod b greater than 1. Second summation is standard formula. If you want to cross check on your own, take specific numbers for a, b's are like this. Okay. Similarly, think of this. Now continuous impulse response is given. The question is for what values of alpha beta system is stable. Continuous impulse response is given. For what values of alpha beta system is stable. Actually, for negative time, it should act like a growing exponential, sir. Then only the area will be finite. For your understanding, I am choosing a specific number. Positive time, it should act like decaying. Positive time, it should act like decaying. So integral mod h tau d tau is our requirement. Minus infinity to 0, I have assumed as e power 5 tau. Whereas positive times are e power minus 2 tau, 1 by 5 plus 1 by 2. First integral is 1 by 5, second integral 1 by 2, finite only. So by comparison, we assumed beta positive, alpha negative. Alpha negative, beta positive, then only the stability is guaranteed. Priyanka, sit. Negative time, it should act like a growing exponential. Positive time, it should act like decaying, sir. Then only the area will be finite. Then only the area will be finite. Think of this model. How randomly I choose. I have chosen Mohammed. Hey, bacha, what is that question? I told you in the beginning only for understanding purpose. I am assuming like that. When I am explaining the problem only, I have said that. For understanding purpose, I am assuming beta like +5, alpha like -2, such that you can feel that the area is finite. There is random trial and error. For this interconnected system, find the overall impulse response is the question, sir. Where we are applying the concept of blocks in series. If two blocks are connected in series, what will happen to the overall impulse response or time domain? Convolution. Transform domain, you already know. Multiplication. Time domain, it becomes convolution. Their parallel connection is addition. Their parallel connection is addition. So using this concept, we should answer it. Using this concept, what is the impulse response of the overall system? Aisha, cool ma. That product is Z domain, not here. Input is impulse, output is called as impulse response. If xn is del n, then yn is hn. Nothing is there on the line means it is del n. Don't take one. One means gain, that is transform domain. Input impulse, output impulse response. So first two blocks are connected in parallel, that is del n plus beta, del n minus 1. That is in series with alpha power n un. First these two are connected in parallel, addition, sir. In series with alpha power n un. Of course, we are convolving them. So in the process of convolving them, blindly convolution property of impulse, sir. In the process of convolving them, some signal convolved by del n means same signal. Some signal convolved by del n means same signal. Signal convolved by del of n minus 1 means shifted. Signal convolved by del of n minus 1 means shifted. Bachas, recollect the convolution property of impulse. Xn convolved del of n minus n naught. That property only we applied, sir. X of n convolved del of n minus n naught is x of n minus n naught. That is first bit answer, find the impulse response of overall system. Second bit answer, is this system causal? Under what condition it is stable? Of course it is causal, because first time it covers from 0 to infinity, next 1 to infinity means causal. For stability, alpha value must be less than 1 or greater than 1, sir. Just now we studied A power n, B power n problem, cross check it. Because it covers positive index, mod alpha less than 1. Because it covers positive index, mod alpha less than 1. Any beta, no problem. Any beta, no problem. As the samples are covered for positive index, for stability mod alpha less than 1, any beta is okay. Similarly, think of this model, sir. Some interconnected system is given, find the overall impulse response. Again, the blocks are in series. So what you have to do? Convolution. Just convolve both the blocks. Impulse response of second system is known. How to get impulse response of first one, sir? Input impulse, output impulse response. Input impulse, output impulse response. So just convolve them. Impulse response of second system is known. First system it is unknown. So just convolve and tell me final simplified answer. Everyone, convolve and tell me, sir, what is the final simplified answer? Again, we need convolution property of impulse for mathematical simplification. Zero. What zero? No. Kiran Kumar, you also check. Bhanu Prakash, check. I asked you very clearly, tell me final simplified answer. Chandrika, that also you can simplify, ma. Akil, you are right. Marisetti Akil. Answer is del n. H of n is h1n convolved h2n. That is del n minus half del n minus 1 convolved with 1 by 2 whole power n. Signal convolved by del n means same signal 1 by 2 whole power n un minus 1 by 2 times signal convolved by del of n minus 1 means shifted. Here 1 by 2 whole inverse is 2 1 by 2 cancellation. 2 1 by 2 cancellation such that the common multiplier is 1 by 2 whole power n times un minus u of n minus 1. What is this bracket term? Simply del n. So it is 1 by 2 whole power n into del n. Any signal multiplied by impulse means product property of impulse. 1 by 2 whole power 0 into del n. Impulse existed 0. That is simply del n. First you apply convolution property of impulse. First difference of step sequence is del n. Again, it becomes product property of impulse. Actually, if you solve this example by Z transform, it is single step. Y1 Z by XZ is 1 minus half Z inverse. For this second term, 1 by 1 minus half Z inverse. If you apply Z transform, it is a single step answer, sir. Of course, this is what we studied few minutes before as invertibility property. As both systems are inverse to each other, we got the final answer as del n, sir. As both systems are inverse to each other, we got the final answer as del n. If you apply Z transform, it is only single step answer. Time domain, some enjoyment is needed. Mathematical simplification. Most of the fellows will stop here. Last step is product property. Impulse exists at 0, 1 by 2 whole power 0 is 1. Impulse exists at 0, 1 by 2 whole power 0 is 1. Abbo, so many expressions you have typed. I asked you very clearly, find the final simplified answer. Everyone typed this expression to me. See here, emotional fellows, you have typed me this one, 1 by 2 whole power and times half. That is the reason very clearly I asked you. Find the final simplified answer. So I want to clarify one point for you. Why these table characteristics are valid only for LTI system? Why the table characteristics are valid only for LTI system? Let me explain clearly with one example. Suppose we have taken a general system like e power xn. We observed this as stable system or unstable system, sir. Yn equals to e power xn. We observed that as stable or unstable. Om Sri, go to first class. Don't ask me such type of questions. If you are in front of me, I would have beaten you. Differentiation converted to difference, that logic we studied here. D by dt of ut. First differentiation converted to first difference. We observed this as stable system. Very good. E power finite value is finite. Listen first. Now let us verify the stability with impulse response logic. Input impulse, output impulse response. Input impulse, output impulse response. So what will happen to that expression, sir? Xn is del n, Yn is Hn. Xn is del n, Yn is H of n. How to check stability with respect to impulse response word? Sigma mod Hn must be finite. Sigma mod Hn must be finite. If I take n value minus 1 e power del minus 1, that is e power 0, 1, because every fellow knows discrete impulse is defined only at origin with amplitude of 1, sir. N value 0 means e power del 0, which is e. N value 1 means e power del 1, that is e power 0, 1. Like that, when you solve the impulse response for infinite length, when you solve the impulse response for infinite length, everywhere the answer is 1 except at 0. Everywhere the answer is 1 except at 0. 1 added infinite times, answer becomes infinity. 1 added infinite times, the answer becomes infinity. Means it is unstable. Why original system is stable? Why it becomes unstable now? We have said that this is stable, but by using impulse response concept, why we got the same system as unstable? Tell me the reason. Anyone? Sigma mod Hn must be finite is the condition for LTA. Why that stable system becomes unstable? Who is unbounded? Pratap, you or me? Yes, you have typed unbounded. What unbounded? No. Nitish, very good. Perin Kumar, Chandrika, correct. Because input impulse, output impulse response is valid strictly for Wood systems. Linear time invariant, exponential is non-linear operation. Applying that concept here is wrong. Solving this problem by impulse response logic is wrong. Sigma mod Hn finite. That logic itself is wrong. Because impulse response word is strictly valid only for Wood systems. LTI system. Only for linear time invariant system you can apply that logic. So this is a blunder mistake in all our local great authors, Ramesh Babu, Nagur, Kani. You will find out bunch of books in libraries. It is a conceptual blunder. Don't use it. That is the reason I stressed in the first slide. Only the word LTA system is used means use these table characteristics. If it is general input output, you already know it. If it is general input output. Applying that concept here is wrong, sir, because exponential is non-linear. By listening online classes, most of you are responding in the chat box also like online answers only. Illogical answers. Improve your logic. Impulse response term is valid only for LTI system, linear time invariant. Given exponential operation is non-linear. Applying impulse response word for that system is wrong. We can go for state space, but no need for signals. State space means multiple input, multiple output. We are always dealing with single input, single output. Okay, moving to next slide. Please respond for this true false questions here one by one. Determine whether each of the following statements are true or false. Justify your answer. First statement, the cascade of non-causal LTI system with the causal one is necessarily non-causal. We want to cascade two blocks. One is non-causal block, the other one causal. We are saying overall system must be necessarily non-causal. Is it true or false? One system we want to take non-causal blocks are. Another system we want to take causal. It is stated it is necessarily non-causal. False statement. If I choose del of n plus 3, another one del of n minus 6 are. After convolving them, the resultant answer is del of n minus 3, which can be causal. But the word necessarily non-causal is used. False. Think of second statement, everyone. If an LTI system is causal, then it is stable. Second statement. Of course, it is also false. Because if I choose RAM signal, RAM signal is causal. Stability means area, integral 0 to infinity tau d tau jump. Causality is not guaranteeing stability. Not only that, you take a growing exponential, sir. It is also causal, but unstable, unbounded. False. Causality never guarantees stability. Causality never guarantees stability. Think of the third one. H of t is the impulse response of an LTI system which is periodic and non-zero. Non-zero means that periodic function has finite amplitude, sir. Non-zero in the sense periodic function has finite amplitude. Then the system is unstable. This will be true because suppose I have taken a periodic function like this, repetition of triangles. It may have finite amplitude for one cycle, but it is of no use. Minus pi to pi, maybe it is maintaining finite amplitude. It is of no use. Integration is done for infinite length. 100% unstable. That too, we are looking for absolute area. It's not normal area also, absolute area. 100% true. What is that last condition asked, sir? Inverse of a causal system is always causal. False. Always causal word is false. Why? If I choose del of n minus 5, that is causal block Hn. What is the inverse block we are taking to reproduce the answer as del n? From del of n minus 5 to retain del n, we are taking del of n plus 5, that is non-causal. But the word always causal is used. That is false. If it is given as inverse of causal system may be causal, No need to mention the word LTA. Anyway, we are dealing with LTA chapter only. Now, sir, the inverse of causal system may be causal. It can be true. Because you have one well-known example. What is that? What is the first difference of step sequence? Del n minus del of n minus 1 convolved with un is this result. This bracket term covering which index are 0 and 1. This is covering, this is causal, this is also causal. The inverse of causal system may be causal true. Always causal false. From un to produce del n. Every one of us know we are using first difference or not. Del n minus del of n minus 1. The inverse of causal system may be causal is true, sir, because there is a chance. Always causal is false. So to answer this question, we must be careful with that words. Because what words are used here? Necessarily, maybe, must be, like that. It is not only knowing that conditions are. You must understand the English language properly. That is the reason English subject is also there in GATE syllabus. So be careful. Whenever the word impulse response is used, then only you have to use that table. General input output means external behavior. Our first chapter. Those conditions are different. These conditions are different, sir. Okay. Let me discuss the next topic. Are you there? Everyone? Very good. Some fellows, my shouting will go on there in drowsy mode. Step response of an LTI system. The next concept is step response. What is the meaning of this word step response is? Listen first, sir, everyone. For an LTI system, by applying impulse as input, we are getting output as impulse response. When you apply step function as input, output is step response denoted as S of t. Impulse input, impulse response output, sir. Step is the input means step response is the output. The total system behavior is characterized by impulse response. The total system behavior is characterized by impulse response, but sudden change in the behavior is characterized by step response. Sudden change in the behavior is characterized by step response. Other way, to solve problems mathematically, impulse function is useful, sir. But which is the physically generated signal in the lab, we can check by applying UT as input. Impulse function is used only to solve problems. Physical verification is done by applying ut as input. Because it is an LTI system, whatever relation that is okay for input, same thing is equally true for output. We know del t is d by dt of u of t. So what will happen to their outputs are del t replaced as h of t, d by dt of ut replaced as s of t. Differentiation of step response is called as impulse response. In the opposite way, step response is integration of impulse response. Step response is integration of impulse response. Whatever happens to input, same thing happens to output. Whatever happens to input, same thing happens to output. Del t input, h of t output, ut input, s of t output. Think of everyone how these formulas can be converted in discrete case. Differentiation converted to what? Difference. Differentiation converted to difference. Integration converted to what, sir? Summation. Integration converted to summation. Funny fellow, latest ESC objective paper. This is also a question. Step response is defined as integration of impulse response, differentiation of impulse response, like that. There is no need to by heart any formulas. Be thorough with introduction. What is del t ut relation? D by dt of u of t is del t. There del t, what is the name now? H of t. There u of t, what is the name now? S of t. Okay. The total system behavior is characterized by impulse response. Sudden change in the behavior is characterized by step response. Sudden change in the behavior is characterized by step response. Let us discuss few examples. What is the need of introducing these mathematical relations? Let us discuss few examples, sir. I'm moving to next slide. Suppose input is given as u of t minus 4 and the impulse response is e power minus 3t ut. Of course, in convolution chapter, this is the first problem we solved by graphical method, folding, shifting, multiplication, and integration. Input u of t minus 4, impulse response like decaying, exponential, which is not at all needed. What is the direct approach is, whenever the input is step function, output is called as step response. Whenever the input is step function, output is called as step response. What is the relation between step response and impulse response means? Integration of impulse response. So because it is positive sided, 0 to t e power minus 3 tau d tau, just simplify, this will be the result. Just simplify, this will be the result. Directly substitute here. 1 minus e power minus 3 into t minus 4 by 3. For t minus 4 greater than 0, t greater than 4. Whenever input is step function, output is called as what, sir? Step response. Integration of impulse response is called as step response. So we got output. If you know s of t, output is what? S of t minus 4. Simply t is replaced as t minus 4. Without doing any convolution, We got the answer, sir, without doing any convolution. Input step function, output step response. Integration of impulse response is called as integration of step response is called as integration of impulse response is called as step response. In a similar way, suppose I have given step response like e power minus t ut and the input is given as ramp. Asked for output, sir. Instead of impulse response, I have given step response. Instead of impulse response, I have given step response. Input is ramp. Asked for output. First, everyone listen. Output is input convolved by system. That is input convolved by differentiation of step response is impulse response. S dash t. But if you want to differentiate S of t, we should apply UV rule. One time differentiation of exponential, another time differentiation of ut. That will be lengthy. If you are unable to take derivative of one function, interchange the derivative. Xt convolved S dash t also equivalent to what, sir? X dash t convolved S of t. Output is input convolved by system. What is H of t here, sir? Differentiation of step response. Rather than differentiating this function, I am interchanging the derivative. Why? Differentiation of ramp is easy compared to decaying exponential. Differentiation of ramp is easy. So what is the answer? Ut convolved e power minus t ut. Ut convolved e power minus t ut. Yesterday, so many times we enjoyed this. It is nothing but 1 minus e power minus t ut. So many times we used that formula yesterday. If you are unable to take derivative of one function, interchange the derivative. Interchange the derivative. We can do that also. Rohan Kumar. How to avoid it is my target. Okay, moving to next slide. If step response is given by 1 minus e power minus alpha t ut, try to get h of t, sir, everyone. S of t known, we want h of t means differentiation of step response is impulse response. Carry on. Differentiation of step response is impulse response. Take S of t and try to differentiate it. Actually, this is like ut minus e power minus alpha t ut. We know differentiation of step response is impulse response. Here we should apply UV rules. D by dt of S of t. So what is differentiation of steps are? Impulse minus, first time what is differentiation of exponential? Minus alpha e power minus alpha t ut plus e power minus alpha t as it is. What is differentiation of ut, sir? Del t. First time differentiation of exponential means minus alpha e power minus alpha t ut. Next time exponential as it is, differentiation of ut is del t. According to product property of impulse, second quantity is del t. Impulse exists at 0, e power 0 1 sir. So del t cancellation. What is the new answer? Alpha e power minus alpha t ut. Alpha e power minus alpha t ut. Simply differentiation of step response is impulse response. But practically this approach is never followed, sir. Because from step response, if you want to get impulse response, what is the system to be designed? Differentiator. Probably you are aware, differentiation in time amplifies the high frequency components of the signal. Generally what we are learning, sir, differentiator acts like high pass, integrator acts like low pass filter or not. Differentiation in time amplifies high frequency component of the signal, which is practically considered to be noise, because noise has wideband spectrum. Okay, once we start frequency domain, you will understand that word. When you want to differentiate in time, it is amplifying the high frequency components of the signal. In general, high frequency component of a signal is treated as noise. Our target is suppression of noise, but we are increasing the noise. So practically this approach is never used. Mathematically, you can enjoy that formula. In controls also, when you are learning state space, there we are solving differential equations by using integrator, adder, multiplier. Actually, we are solving differential equations, but their implementation is done by which elements are? Integrator, adder, multiplier. Why not differentiator? This is the reason. Differentiation in time amplifies high frequency components of the signal. Differentiation in time amplifies high frequency components of the signal, which is generally considered to be noise. Because we are proving after 3-4 hours, maximum energy or power is there only in the low frequency region. Under Parsel's theorem, we are proving it, sir. maximum energy or power of a signal is there only in the low frequency region. So for any type of signal, we will neglect high frequency amplitudes. For any type of signals, we will neglect high frequency amplitudes. Mathematically, we can enjoy that formula. Practically, this approach is not used. Please think of this question. If step responses of two LTA systems are S1T and S2T, what is cascaded step response? In terms of S1 and S2. That is my question. Every fellow knows cascaded impulse response means convolution of individual blocks are. Now my question is, what is cascaded step response in terms of S1 and S2? What is cascaded step response in terms of S1 and S2? Think of and answer me. What is cascaded step response in terms of S1 and S2? Just integrate it. Integration of impulse response is called as step response. Integrate it, sir. If we integrate it, what will happen? Right side, any one term is integrated. It is like integral H1T, H2T as it is, or H1T as it is integral H2T. This quantity is what? Cascaded step response. This is S1T convolved S2 dash T, or lower one S1 dash T convolved S2T. Both answers are correct, but the answer never equals to direct convolution of step responses. Integral H1T is S1T, sir. H of T is S2 dash, or H1 means S1 dash T convolved with S2T. Answer never equals to direct convolution of them. Both results are correct. S1T convolved S2 dash T, or S1 dash T convolved S2T. Okay. I'm going to next slide. Please think of this, sir. Find the step response of the system if impulse response is 0.5 whole power n un. Discrete impulse response is given, asked for step response. Discrete impulse response is given, which is acting like decay, asked for step response. Normal formula is what, sir? Discrete case. You can check your notes. Sigma minus infinity to n hk. But now it covers only positive index 0 to n 0.5 whole power k. Sigma m equals to 0 to n minus 1. Alpha power m means 1 minus alpha power n by 0 to n minus 1 means total n samples. Otherwise, if you want to write 0 to capital N, this side alpha power n plus 1. Very standard formula. So 1 minus 0.5 whole power n plus 1 by 1 minus 0.5. That is the answer. Directly summation of impulse response is called as step response. Simple logic, sir. Out of two given signals, whenever one signal is step function, integrate the other signal, you will get the output. Out of two given signals, whenever one signal is step function, integrate the other signal. If it is discrete, summation. If it is discrete, summation. Whenever we know impulse response, asked for step response means what we have to do? Continuous case integration, discrete case summation. Okay. I have written in terms of general NMA. I have not obtained till infinity. S of n left side quantity is in terms of n only. That is geometric progression only. This particular question is copied in different exams. Very good question. Think of and answer. Very good problem. An LTI system with input un produces the output as del n. For the same system, if you apply NUN as the input, what is the output? We have taken LTI system. U of n is the input means we got output as del n. For the same system, when you apply NUN as input, means RAM sequence. What is the output? UN is giving del n, n into UN is giving what? Yes, Sriram. Correct. Trivikram, correct. Marisetti Akil, correct. UN un is becoming del n means don't say n into un is n into del n. That is wrong. From un to get del n, we know it is first difference formula. From un to get del n, we know it is first difference formula. Because un minus u of n minus 1 we studied as del n. So the output becomes nun minus n minus 1 into u of n minus 1. Nun minus n minus 1 into u of this quantity is like n into del n, which is 0 into del n, simply 0. So what you are left with, sir? U of n minus 1. Un is giving del n means don't say n into un is n into del n. That is wrong. Answer is decided by system operation. From un to get del n, what is the system we need, sir? First difference. Take the first difference of the other input. For an LTI system, scaled input is scaled output. If scaling factor is a fixed number, 3 into xn, 3 into yn, 2 plus j3 into xn, 2 plus j3 into yn. N into xn is not n into yn. That is wrong. Wantedly, first option he will give 0. Second option un. Third option u of n minus 1. So be careful, sir. Wantedly. First option, some fellows emotionally they may take n into del n 0. Some fellows with some other emotion un. Both are wrong. Correct answer is what? U of n minus 1. For an LTI system, scaled input is scaled output if scaling factor is a fixed number. It should not be variable function of time. Okay, whatever we discussed till now is the time domain analysis of signals and system. That is introduction and convolution. Now we are entering into the frequency domain concept, for which the mathematical tools are Fourier series and Fourier transform. For which the mathematical tools we are using are Fourier series and Fourier transform. First, listen everyone. I'll give time for noting down. Fourier series and Fourier transform are the mathematical tools that are providing the frequency domain concept for us. Generally, what is the need of Fourier series means? Everyone will say, we want to express a periodic signal in terms of sinusoidal components. We want to express a periodic signal in terms of sinusoidal component. But the aim of this fellow, sir, one period, many frequencies. He wants to maintain single period. From that, he wants to generate multiple frequencies. Mathematically, to say convert omega naught to n omega naught. Omega naught means single frequency. N omega naught means nth harmonic of the fundamental frequency. How we are giving definition of Fourier series is, it is an approximation process where a non-sinusoidal waveform is converted to sinusoidal such that all periodic signals are represented in unique form. It is an approximation process where a non-sinusoidal waveform is converted to sinusoidal such that all periodic signals are represented in unique form. Suppose if you have taken this signal, it is periodic but non-sinusoid. Or if you have taken another signal like this, this is also periodic signal, but again, non-sinusoid. We want to approximate these non-sinusoids in the form of sine and cos, such that the transmission becomes easy. Network theory, what is the habituated enjoyment? A sinusoidal input to LTI system, a linear system will reproduce again sinusoidal output. For a RC RLC, if you apply AC source, the steady state response is magnitude scaled and phase added version of original signal or not. That is possible only with sinusoids, not with non-sinusoids. Okay? And that too, once you convert the non-sinusoid to sinusoid, sir, we are in a position to check out of the available periodic signals, which particular signal is asking for least power. A position to check out of the available periodic signals, which particular signal is asking for least power. Why we are bothering about the term power? When you do an experiment in the lab, we are giving certain power supply. Assume we have given 5 volts power supply, sir. Assume out of which if 4.4 volts is taken by periodic signal itself, out of that 5 volts, if 4.4 volts is taken by periodic signal itself, how much voltage we are left with? 0.6 volts. If you want to drive transistor from one region to another region, we require some minimum voltage. That information is not visible in time domain. You can extract the power taken by each periodic signal correctly only in frequency domain. That is another reason we are converting non-sinusoid to sinusoid. What are the advantages of studying this topic? One point, we can find out spectral width. Means up to what range of frequencies the maximum power is there. The second point is we can find out the steady state response due to periodic inputs easily. That is what sinusoidal input will guarantee sinusoidal output. But why Fourier wants to convert non-sinusoid only into sinusoid? Why not any other waveform? Means, listen. That is what we are learning as orthogonality concept. If the area under inner product of the signals is 0, we can say the two signals are orthogonal to each other. If the area under inner product of the signals is 0, we can say the signals are orthogonal to each other. Why do we need actually orthogonality? To obey our starting statement, sir. What is the starting statement? One period, many frequencies. Without changing the time period, if you want to increase the number of clock cycles, the chance is there only for sine and cos function, because it is resulting in odd product, area under odd signal 0. Graphically, I am showing here. Observe here. This is sine t 1 cycle. Sine 2t means within the same period, how many cycles are covered? Within the same period, 2 cycles are covered. Sine 3t means within the same period, how many cycles are covered? 3 cycles are covered. We are not at all changing the time period, but number of clock cycles are increased. What for we are doing this? When you add all these terms with certain amplitude levels, we should reconstruct that non-sinusoid shape as it is. When you add all these sine or cos function with certain amplitudes, you should reconstruct that original graph as it is. In that process, funny fellow, in that process, how many number of sine and cos functions we are adding? That is unknown for us, sir. That is the reason the heading series. In that process, how many number of sine and cos functions we are adding? That is unknown. Without changing the time period, you can increase the number of clock cycles only when one wave is orthogonal to other wave. Sin t into sin 2t integration, if you perform 0. Sin t into sin 3t integration also you perform 0. So if anyone asks you, why do we require orthogonality, means without changing the time period, we want to increase the number of clock cycles. So every signal must be orthogonal to other signal. We are learning two forms of series, trigonometric Fourier series and exponential. If we have orthogonal signals, we have chance of writing Fourier series. Everyone listen one more style. The other way of explaining this point is one period many frequency. Sin 2 theta expansion is what? 2 sin theta cos theta, means sin theta reference. Sin 3 theta expansion is what, sir? 3 sin theta minus 4 sin cube theta. Again, sin theta is reference. You can generate the higher harmonics because of sine curve. So because of Fourier's idea only, every branch of engineering is there, sir, except computer science. That fellow's only enjoyment is changing the code. Okay. Just a minute. Fourier series is used by us communication and signal subject. Fourier series, Fourier transform. Electrical fellows, they have power electronic subject there, they are using it. Mechanical and civil, they have heat transfer as a subject. So roughly what we are going to do, here I am showing. I want to convert this rectangular pulse to sine or cos function. First time I have done approximation as only one component, but still it is not correct approximation. Because when rectangle is equals to one sine wave mean, we become stupids. Next time it is approximated as sum of 5 terms like C1 sin t, C2 sin 2t, like that, sir. Next time the same waveform is approximated to 11 harmonics. Roughly after observing 49 harmonics are added, 49 sine and cos functions are added like this, you can feel that the original rectangular pulse is recovered. So what point you have to remember in our discussion is easy way, sinusoid single frequency, non-sinusoid multiple frequency. If I use the word sin 3 pi t, 3 pi is the frequency. If I say cos phi t, 5 is the frequency. Sinusoid single frequency, non-sinusoid multiple frequency. So the target of this chapter is that only. Take single period, try to generate multiple frequencies. So what we are going to learn in this chapter is mainly 1 point, verification of symmetry. The 4G technology which we are using, that is linked to OFDM, orthogonal frequency division multiplexing. That is also linked to this, where we will use multiple subcarriers or FC1, FC2 like that. When a phone call is made, which antenna is taking that particular call? The nearest antenna. In that process, we will have multiple subcarriers. So when one subcarrier is picking the signal, how the other subcarriers are obeyed? By using orthogonality principle, they are obeyed. That is what rectangle in time domain becomes a function in frequency. There I will give a better explanation. 4G technology is using OFDM, orthogonal frequency division multiplexing. So area under inner product of the signals is 0. That is a requirement. So the target of this chapter is, first thing we are learning is verification of symmetry, sir. Second point, spectral analysis. We will draw magnitude and phase spectrum. The last concept is properties of Fourier series. Till I complete this chapter, everyone remember this, only this point. What is the target in Fourier series? Take single period, generate multiple frequency, convert omega naught to n omega naught. Steady state response, Mohammed. You have not studied network theory. SSR stands for steady state response. How to remember this point in easy manner, sir? Sinusoid is single frequency, non-sinusoid is multiple frequency. Sinusoid single frequency. Non-sinusoid is multiple frequency. That is the easiest way of remembering it. Actually, this fellow Fourier, he has given total 4 frequency domain concepts for us, in which one variable is the time, another variable is frequencies are. Time may be continuous or discrete. Frequency may be continuous or discrete. Time is continuous, frequency is discrete. That is what continuous Fourier series just now we started. Time continuous, frequency discrete. If both are continuous, that is called as CTFT. Time discrete, frequency continuous is DTFT. If both are discrete, that is DFT or DFS, because they have only small change. All the frequency domain concepts given by Fourier are these 4. They are actually linked to which points are? Time may be continuous or discrete, frequency may be continuous or discrete. Okay. So that fellow has prepared these 4 blocks very easily. But for us, almost it is 25 to 30 hours enjoyment if you see the details of the topics. Okay. I don't want to explain the derivation done by Fourier, which will spoil your chip. Remember, as of now, the target of this chapter is take one frequency, generate multiple frequency. Take one frequency means sinusoid. Sinusoid means single. Multiple frequency means non-sinusoid can have multiple frequencies like this. Okay. Please go through it. This is the first slide of Fourier series. First slide. It is an approximation process where a non-sinusoidal wave converted to sinusoidal. Everyone utter the name of Fourier once. Fourier. Another time also you utter. It will look like what? Fourier BTech. All Fourier BTech. This fellow is there with us. Esma Aisha. He is Fourier only. Background pick. Because of 2 fellows, my life is going on from last 2 years mainly. There are so many other fellows. Main fellow Fourier. After that, OpenAM Nawab, who have made me very clear to teach the subject, signals. The applications of Fourier transform, there is one book called as Bracewell, sir. Bracewell. Excellent book. There you will also find 2D, 2-dimensional. We are discussing only 1 dimension, but there you will find 2-dimensional also. Anyway, that is like research. Competitive exam, what is needed that you study first. At the age of 9 only, this fellow invented a formula, Fourier. Till the last years of Fourier, they have not accepted his paper, sir. Till the last years of Fourier. There are some other fellows which we are studying as Dirichlet conditions. Laplace, Lagrange, Leibniz, all these team of members, they have rejected the paper of Fourier. That we are learning as Dirichlet conditions later on. Okay, this is the first slide. Why do we need orthogonality? Means to obey the first statement without changing the time period, we have to increase the number of frequencies. That is possible by sine and cos. We are not changing the sine wave. The time period kept as is, but number of clock frequencies are go on increased. What for we are doing this? If we add all these functions with certain amplitudes, we should reconstruct the non-sinusoidal graph like this. Okay. So what are the four forms of frequency domain analysis we are learning? Continuous Fourier series, CTFT, DTFT, DFT, and DFS. For this chapter, time is continuous, frequency is discrete. For this chapter, time is continuous, frequency is discrete. So what are the types of Fourier series we are learning? Two forms, trigonometric Fourier series, one form, exponential or complex Fourier series, another form, sir. We have Legendre Chebyshev Fourier series also, they are not useful for us. Trigonometric Fourier series and exponential Fourier series we are learning. Okay, I'm going to next slide. Here some rough graph I have shown. When you take a rectangular pulse, by adding multiple sine functions, it is converted to original graph. So after 49 sine terms addition, we feel the original graph is almost recovered. Non-sinusoid is almost recovered. First, let me explain the trigonometric Fourier series. Everyone listen carefully. First, let me explain the trigonometric Fourier series. Okay, moving to next slide, sir. So what we are doing in trigonometric Fourier series is by taking the fundamental frequency omega naught, we are trying to generate the higher harmonic frequencies. N into omega naught corresponds to nth harmonic of the fundamental frequency. N into omega naught corresponds to nth harmonic of the fundamental frequency. Listen first. If you take a non-sinusoidal periodic function as g of t, if you take a non-sinusoidal periodic function as g of t, how it can be written as sum of cos and sine means we are writing a series like this: a0 plus a1 cos omega naught t, a2 cos 2 omega naught t, etc. b1 sin omega naught t, b2 sin 2 omega naught t, etc. What does that a0, a1, a2, b1, b2 represent, sir? They are the amplitudes of the respective harmonic components which are deciding the power content of the signal. They are the amplitudes of respective harmonic components which are deciding the power content. Why b0 is missing in the series? It is multiplied by 0. a0 stands for a0 cos 0. b0 into sin 0 is 0. We have not missed it, sir. b0 into sin 0 becomes 0. As we have multiple terms, we can write this as a0 plus sigma n equals to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. That is the standard mathematical expression of trigonometric Fourier series. That is a standard mathematical expression of trigonometric Fourier series, where a0 is the DC or average value, a and bn are the AC coefficient. For a given problem, our target is solving for the three coefficients. If you know the three coefficients, then we'll know the Fourier series representation. For a given problem, our target is solving for the three coefficients. Listen, I'll come back to this slide. First, you listen. How to solve for the three coefficients means we are using the predefined integrals of general mathematics. What is integration of cos or sine function for one cycle? When you integrate cos or sine function for one cycle, the answer becomes 0. N not equals to 0 for cos function, because cos 0 is 1, first integral. Similarly, if you take cos m omega naught t, cos n omega naught t dt, sir, for equal value of m and n, answer becomes t by 2. Unequal value is 0. Because if m is n, here it is cos square theta. If m is n, it is cos square theta. What is expansion of cos square theta? 1 plus cos 2 theta by 2. Integral cos 2 theta becomes 0. Integral 1 by 2 is t by 2, sir. Same relation is equally true for sine into sine. Sine m omega naught t, sine n omega naught t dt. Same relation is equally true. But if you take sine into cos product, if you take sine into cos product for all values of m and n, answer is 0. By using these predefined integrals, we are in a position to find out the respective coefficients by using these predefined integrals. Suppose we want to get a naught in equation 1, what we have to do? Simply integrate this equation for one period. Simply integrate this equation 1 for one period. Integral 0 to t g of t dt as it is. Integral 0 to t g of t dt as it is. Integral 0 to t a naught dt. But what is integration of cos or sine functions are? Our first integral, answer is 0 or not. So simply integrate equation 1 for one period. That will retain a naught formula as 1 by t integral 0 to t g of t dt. This is the DCR average value. This is the DCR. Of course, this formula already I have given for you under periodic function. Area of signal over one period by area of signal over one period by fundamental period. Fundamental, that is a naught. How to get an means multiply both sides by cos and integrate for one period, sir. Multiply equation 1 both sides by cos and integrate for one period. G of t cos n omega naught t integration as it is. A naught into cos not needed. We are solving a and bn from first harmonic onwards. A naught story is over. Cos into cos becomes cos square. What is that integral answer? T by 2. Sine into cos integration becomes 0. Multiply both sides by cos and integrate for one period. That will retain an as 2 by t integral 0 to t g of t cos n omega naught t dt. An contains cos means what is the change for bn, sir? An contains cos means bn contains sine term. By using these predefined integrals, we are in a position to find out the respective coefficient. Of course, the integration limits need not be from 0 to t, sir. Symmetrical limits also you can cover minus t by 2 to plus t by 2. But compulsory we have to cover one period. Compulsory we have to cover one period. First go through it, everyone. Any practical periodic function that can be generated has this Fourier series form. Any practical periodic function that can be generated has this Fourier series form. Please go through the expression. Our target here is finding out for three coefficients A naught, A n, B n. Offline class are started in all areas. In engineering college, sir. All areas, the offline class are started at. No? Achha. Still online emotion is going on. Okay. In the last 2 months, I completed 2 offline, 2 online. This I started, still one more is there, offline. Going on. Okay, I'm going to next slide. So by using these predefined integrals, we are in a position to find out the three coefficients. I will show you one funny thing. This is sin t. This is cos t. Black colored thick one is sin t. Dotted one is cos t. The product of them is what? Half sin 2t. The product of them is half sin. So it is covering how many cycles within that? Amplitude reduced. The area under them is what? Here cancellation, here cancellation. That is what our build up, this formula, integral sin t into cos t is 0. Okay. This original black color one, sin t, this is cos t. When you multiply them, it becomes half sin 2t. The area becomes 0 or not? By using these relations, we may solve for A naught, A n, B n, but there is no need to calculate every coefficient here. There is no need to calculate every coefficient here, sir. Based on the symmetry of the signal, some of the coefficients will be 0 based on the symmetry. That I will show in the next slide as a table. I'm moving to next slide. Based on the symmetry of the signal, some of the coefficients will be 0 based on the symmetry of the signal. These are the table conditions. Generally, we are using three forms of symmetry: even symmetry, odd symmetry, half wave or rotational symmetry. What is even signal condition? Everyone knows time domain gt equals to g minus t, for which bn is 0. Why bn is 0, sir? What is bn formula? Just now we have written 2 by t integral g of t sin n omega naught t dt. Okay, we are treating our signal as even, sine is odd. We are treating signal is even, sine is odd. Even into odd becomes odd. Area under odd signal 0 or not. That is the reason bn is 0. If you take odd periodic function, dc cosine terms are 0. Half wave or rotational symmetry, the symmetry of that signal is decided by half period. That is the reason half wave or rotational symmetry. A naught, of course, 0. A and Bn both contains odd n, means odd harmonics only. Everyone be careful with two words, sir. Odd symmetry. Odd symmetry means we are speaking in time domain gt equals to minus g of minus t. Odd harmonics means we are speaking in frequency domain omega naught, 3 omega naught, 5 omega naught, like that. In the time domain, they corresponds to half wave symmetry. So be careful when you are using that word. Odd symmetry means time domain. Odd harmonics means frequency domain. In time domain, it corresponds to which symmetries are half wave symmetry. Of course, by using this table, we will find out the respective coefficients. That is good. But how to draw the shape of the spectrum? How we can draw the shape of the spectrum? See, whatever the periodic function we selected, suppose it is not at all satisfying any symmetry, then the problem will come, sir. What problem will come? All three coefficients are defined. Whatever the periodic function we have chosen, if it is not at all satisfying any symmetry, then all three coefficients are defined. We cannot draw the shape of the spectrum easily, because if it has a naught, a n, b n, which term you will take as reference to draw the shape? Cos term or sin term? If you say cos, I will say sin. That chance is there. For that reason, to draw the shape of the spectrum, we are taking polar form of trigonometric series. To draw spectrum, equation 1 changed to, equation 1 is modified as a new expression like this: d naught plus sigma n equals to 1 to infinity dn cos n omega naught t plus theta n. Listen. From which slide? From 18th slide, we jump to 21 slide. Instead of an cos plus bn sin, what is the new term I have written, sir? dn cos n omega naught t plus theta. And what is the expansion of this one? Cos a cos b minus sin a sin v. So by comparing equations 1 and 2, what is the conclusion you will get? Instead of an cos n omega naught t, an place which term we got? dn cos theta n. bn sin omega naught t, bn place which term we got, sir? Minus dn sin theta n. So by comparison, d naught equals to a naught. What is an square plus bn square, sir? Right side, dn square. Mod dn is root of an square plus bn square. Root of an square plus bn square. That is called as magnitude spectrum. Magnitude spectrum. Sin theta by cos theta means tan theta. Theta n is tan inverse of minus Bn by An, that is called as phase spectrum. This is what you are expecting finally, the spectrum graph, which is decided by the polar form. It is decided by polar form. For a given problem, try to draw the shapes are d naught is a naught, mod dn is root an square plus bn square, theta n is tan inverse of minus bn by n. From these two expressions only I have written. Okay. So on the y-axis you may draw either magnitude or phase angle. On the x-axis it is n omega naught. Till now it is a t or tau symbol in the last chapters. Now onwards it is frequency. You are going to observe for various frequencies the impulsive spectrum like this. That is what we have made in the comparison table. Fourier series spectrum is discrete. Fourier series spectrum is discrete. There are two advantages of taking spectrums. First advantage, at every frequency you can observe the magnitude and phase. At every frequency you can observe the magnitude and phase, which is not visible in time domain graph. Second advantage, up to what range of frequencies the maximum power is there. For the periodic function, the power is there up to 5th harmonic, 11th harmonic or 20th harmonic. Because as frequency increases, magnitude decreases. So up to what range of frequencies the maximum power is there. That point also we can check. Just go through the relations. After calculation of the coefficient, final enjoyment is what? Sketching the shape of magnitude and phase spectrum. That is final enjoyment. So after completion of this, take a short break of 20 minutes, sir. Okay? After completion of this, take a short break for 20 minutes. Okay, let us continue our discussion. So in trigonometric form, we have to calculate three coefficients A0, A, Bn. But based on the symmetry of the signal, we have chance of making some of the coefficient 0. Later on, what is our job? Sketching the shape of magnitude and phase spectrum. So for understanding purpose, let us discuss one example, sir, for understanding purpose. What is the trigonometric Fourier series form of the signal graph given? If a signal graph is given like this, how to get the trigonometric Fourier series form? First, we have to check its fundamental period and the symmetry of the waveform. First, we have to check its fundamental period as well as symmetry. So, what is the least period of the signal? We can take minus pi to plus pi segment as reference. Least period 2 pi, omega naught becomes 1. Least period 2 pi, omega naught becomes 1. Of course, it exhibits odd symmetry. I hope you have recognized it, sir. Everyone, xt equals to minus x of minus t. It is perfectly anti-symmetric. So A naught n are 0 according to the table because it is odd periodic function. DC cosine terms are 0. Our job is calculation of Bn. Our job is calculation of Bn. So what is Bn definition, sir? Formula 2 by t integral x of t sin n omega naught t dt. By using that expression, we have to calculate Bn, sir. 2 by t integral x of t sin n omega naught t dt. It is looking like a positive ramp or negative ramp. Minus pi to plus pi interval, it is a positive ramp or negative ramp. Positive ramp, slope v by pi into t. Height by width v by pi into. Everyone solve for Bn. The required data I have given for you. Time period 2 pi, fundamental frequency 1. Mathematical expression of xt is also available. In this problem, we can use another logic. What is that is? Signal is odd, sign is also odd. Signal is odd, sign is odd. Product of two odd signal means even. Area under even signal is 2 times one-sided area. So 2 by t becomes 4 by t. Integration is done for half period, sir. 2 by t becomes 4 by t. Integration is done for half period. So now you substitute the data and simplify. Now you substitute the data and simplify, sir. Four by 2 pi integral 0 to pi Vt by pi sin nt dt. Omega naught is 1, sir. 4 by 2 pi integral 0 to pi Vt by pi sin nt dt. I am giving 3 minutes time for you. Simplify and tell me the result. Don't ask me integral UV rule. That is your job. I will not do it. Simplify that integral. Tell me the answer. Integral t sin nt. Simplify and substitute the limits are 0 and pi. So what is integral t sin nt here, sir? Minus t cos nt by n plus sin nt by n square over the limit 0 to pi minus t cos nt by n plus sin nt by n square. What is the general solution of sin n pi? 0. What is the general solution of cos n pi? Minus 1 whole power n. Substitute the limits now. T place pi means pi into cos n pi. Pi into cos n pi. Cos n pi solution is minus 1 whole power n. Sin n pi 0, sir. T place 0 means 0. 0 into cos 0, sin 0, 0. So the simplified answer is 2v by pi n into minus 1 whole power n plus 1. Here minus 1 is there, minus 1 whole power n. 2v by pi n into minus 1 whole power n plus 1. If I want to select only even harmonics, what will be the results, sir? If n is even, this becomes negative. N place 2, n place 4 like that. If I want to select only odd harmonics, that is plus 2v by pi n. N place 1, n place 3 like that, plus 2v by pi n. What, Nitish? What is that result? Huh? Yeah, that's what I'm saying. Why I separated Bn for odd and even harmonics is to find out the phase angles, sir. What is the phase angle formula? We consider tan inverse of minus Bn by n. For finding out the phase angle, I have done the separation. Okay. Let us draw the polar form of trigonometric series. Where we are saying d naught equals to a naught, mod dn is root an square plus bn square, theta n is tan inverse of minus bn by an, sir. Of course, d naught is a naught means in the question 0. Mod dn is root an square plus bn square means simply modulus of bn, sir. Simply modulus of bn. What about the phase angle? For even harmonics, already it is negative. Overall becomes positive by 0 plus 90. For even harmonics, already it is a negative value. Overall becomes positive by 0. Whereas for odd harmonics, it is positive. Overall becomes negative by 0 means minus pi by 2. Plus or minus pi by 2. Even harmonics plus pi by 2. Odd harmonics minus pi by 2. So let us draw this spectrum, sir. Both magnitude and phase spectrum, which I am showing in the next slide. Let us draw the shape of magnitude and phase spectrum. Mod dn and theta n. Modulus of dn is mod 2v by pi n. Of course, this axis is n into omega naught. But in our example, what is omega naught numbers are? 1. Even omega naught is pi, we will not show pi, sir. Just integer numbers will show. Every n is multiple of omega naught. Every n is multiple of omega naught. At 0, we got DC 0 from the last slide. D naught equals to A naught 0. N equals to 1 means what is the magnitude level? 2V by pi. N equals to 2 means V by pi, like that rest of the harmonics. What about the phase angles, sir? All even harmonics pi by 2, odd harmonics minus pi by 2. Even harmonics plus pi by 2, odd harmonics is minus pi by 2. That is the shape of magnitude and phase spectrum. That is the shape of magnitude and phase spectrum. Try to sketch the signal. Please observe who wants 20th slide. Observe it. This is 21, the polar form representation. Then we started solving this question. Actually, the main point we have to observe in this example is what is the symmetry of the original function, sir? What is the symmetry of this function? Odd. What are the phase angles we got? What are the phase angles we got, sir? Plus or minus 90. Whenever you take real and even, fixed phase angle is 0 degrees or plus or minus 180. But if you take real and odd signal, phase angle is plus or minus 90 degrees. Wherever you draw phase spectrum, this concept will never change, sir. You can cross check 100 times. Even function means 0 or 180. Odd signal means plus or minus 90 degrees. Our problem has odd symmetry. This has odd symmetry. We got now phase angles in the graph as plus or minus 90. Real and even function means phase will be 0 or 180. Odd function means it becomes plus or minus 90 degrees. Okay, wait for a few minutes. I have to add some models here. Wait for a few minutes. Okay. See this first example. A periodic signal is given by some expression which is given as sum of sine and cos. What is the amplitude of second harmonic? Everyone tell me what is the fundamental frequency here, sir? 4 and 12 are the given frequencies. So what is the fundamental frequency of the signal? GCD of 4 and 12 means what is the fundamental number? 4. Correct or not? Fundamental frequency 4. So which harmonics are available? This is first harmonic. This is third harmonic. So automatically what is amplitude of second harmonic? 2 4s are 8, that frequency not present. So what is the amplitude of second harmonic? 0. Periodic signal means first you find out fundamental frequency. GCD of 4 and 12 means 4s are. So in the problem it corresponds to first harmonic and third harmonic. Amplitude of second harmonic is expected 2 4s are 8. That frequency is not there. 0. Okay, this is also another easy example. Right side. Which of the following signal is not the representation of Fourier series? You tell me out of the given options, which is looking like non-periodic, sir? Fourier series means strictly periodic. Which is non-periodic there? Last option. Cos 3t plus sin 12t, 3 and 12 common frequency 3. 1 plus sin pi t DC is always an exception. Complex sinusoid e power j60 of course valid. Last one is non-periodic. We cannot express in terms of Fourier series. Non-periodic. Which of the signal is not representation of Fourier series means try to check which is non-periodic function, sir. Try to check which is non-periodic function. Observe this question. For the periodic waveform shown in figure, what frequency components are present in the trigonometric series expansion? Out of A0, A and B, and it contains which components is the question, sir. So check the symmetry. What is the symmetry of the signal? If you know the symmetry, then we can say which coefficients are possible. By direct observation, there is no symmetry. Time period of the signal is 1. If you subtract the DC, then you can observe the symmetry in easy manner. If you subtract the DC, then you can observe the symmetry in easy manner. Suno bachas, what is the DC value of this? Area of the triangle is half base height by fundamental period is 1. So if I subtract 1 from the graph, the graph is going to appear like this. Originally, it is an odd signal for which extra DC is added. 1 plus 1 becomes 2. 1 minus 1 is, this point is shifted to horizon, sir. So it exhibits hidden odd symmetry. What component is hidden inside the signal? DC value. Because it is odd signal, it will have sign terms, sir. After subtracting 1 from this, the new amplitudes are plus or minus 1, which are neatly looking like exhibiting odd symmetry. It is neatly looking like exhibiting odd symmetry. That is the reason the word hidden odd. Because it is odd, it will have sign terms. Extra DC is also there. So DC and sign terms are possible. For verification of symmetry, easily, if you want to verify the symmetry easily, subtract the DC value. Subtract the DC value. Then you can verify the symmetry in easy manner. By subtracting 1 amplitude of 1, sir, we felt it has odd symmetry. It is like clamp the lever. Clamper is a DC restorer or not? Clamper is acting like a DC restorer. Whenever you want to verify symmetry easily, subtract the DC value. That is a technique. Subtract the DC value. We got A naught of 1, sir. DC is there. Because it is odd periodic function, 100% sign terms will be there. So this is a technique. Whenever you want to check the symmetry in easy manner, remove the DC. I'm moving to next slide. Now you think of, for this periodic signal, which symmetry it obeys? Even, odd, or half wave. Of course, the least period is 2 pi, sir. Least period is 2 pi. Even symmetry, odd symmetry, half wave. Come on, come on. By direct observation, there is no chance for evenness. Of course, there is no chance for odd also. Odd means it must appear like this. That segment is not at all there. That segment is not at all there. So maybe half wave. Maybe half wave. What is half wave condition we observed in the table, sir? F of t must be equals to minus f of t plus or minus t by 2. So as the time period is 2 pi, half period is pi, sir. How to check half wave symmetry is, if you take one half as reference, from that we have to generate other half, sir. Yeah, I know. Jyotisha, wait. I know external noise is there, wait. I closed complete, I am in a closed room, but still we are getting that noise. The emotional fellows, still Diwali is not over for some fellows. So how we are verifying half wave condition means, what is the reference segment here? We have chosen, sir. This is the reference segment. Within this, if you take one half, from that you have to produce other half. If you take 0 to pi segment as reference, from that you have to generate which graphs are the other segment. Then only the name half wave has a meaning. Then only the name half wave has a meaning. I will assume upper segment as reference. I will assume upper segment as reference. From that, we have to generate lower one. So f of t must be equals to which conditions are minus f of t plus or minus 5. If this is f of t, what is minus f of t, sir? If this is f of t, what is minus f of t meaning? Amplitude scaling. Later on, left shift of pi units. If you take left shift of pi units, it extends from minus pi to 0. So by taking upper segment as reference, we got the lower segment or not. So 100% it satisfies half wave symmetry. Both AN and BN only for odd harmonics. According to the table we considered, both AN, BN only for odd harmonics. By direct observation, we felt there is no chance for evenness and oddness. That is the reason we verified half wave. How to check half wave, sir? Within the time period, if you take upper segment as reference, from that you have to generate lower. I assumed 0 to pi segment as reference, upper segment. From that we reproduced the lower segment, which is satisfying this condition. So both cosine and sine terms for odd harmonics only. Both cosine and sine terms for odd harmonics only. Take upper segment as reference, try to generate the lower one. As evenness, oddness both failed, we have seen the next combination, sir, that is half wave combination. I am moving to next slide. Now everyone think of and respond. This graph. One of the symmetry must be satisfied, but it is not a rule. A periodic signal may not have any symmetry also. For one of the symmetry may be satisfied, but a periodic function need not have any symmetry. If it doesn't obey any symmetry, all coefficients will find out A naught, AN, BN. The advantage of symmetry is we are in a position to know which coefficients we have to calculate. That is the advantage. Now you think of, sir, here the least time period is 2 pi. 100% it is odd. Also half wave. 100% it is odd, also half wave. Observe here. Odd symmetry, no need to check, everyone can recognize. How to check half wave, sir? Gt must be equals to minus G t plus or minus t by 2. G of t equals to minus G t plus or minus t by 2. Like in the last slide, if I take upper segment as reference, sir, what is the mathematical condition to obey? gt must be equals to minus g of t plus or minus pi. So if that is gt, what is minus gt? Amplitude scaling. What is the meaning of minus g of t plus pi? Left shift of pi units. Of course, we got lower half. So odd and half wave means which terms are? Sine terms only for odd harmonics. Sine terms only for odd harmonics. It has combinational symmetry. Odd is there, half wave is also there. But if you make a direct observation, what is your feeling? Only odd symmetry means immediately you may take first option. So be careful. Don't lose this simple question because of your unnecessary emotions. In the options, odd harmonic word is used means possibility of half wave symmetry. Even and odd, just by looking at the graph only, we can decide. Half wave is taking some time for us. Actually, a signal which has odd plus half wave or even plus half wave symmetry, it is commonly called as quarter wave symmetry. A signal which obeys odd plus half wave or even plus half wave, combined it is called as quarter wave symmetry. Why that name quarter wave? I am explaining here, sir. If signal is odd, what is Bn formula? We know 2 by t integral gt sine of something. But first example, what we have done? Because both are odd functions, we have made 2 by t as what, sir? 4 by t integral 0 to t by 2, we have done integration. It is not only odd, also half wave in this question. It is not only odd, also half wave. Then what is the further change in formula? 4 by t becomes 8 by t. Integration is done for 1/4 of the period. 0 to by 2. Half period means 0 to t by 4. As integration is done for 1/4, it is also called as quarter wave symmetry. As integration is done for 1/4 of the period, it is called as quarter wave symmetry. Sahiti, what is the question and what you are typing? Huh? I have not asked for exact coefficient, ma. Only symmetry I am expecting there. The signal has combinational symmetry. Odd is there, half wave is there, sir. Odd is there, half wave is there. A signal which has odd plus half wave, even plus half wave, they are called as quarter wave symmetry. Be careful. If the word odd harmonics is used, don't forget to check half wave symmetry in the options. I'm moving to next slide. Now you think of, sir. For this, which symmetry is there? Of course, the time period is 2 pi. It is perfectly even. Perfectly even. After removing the DC, you can also feel half wave, sir. Perfectly even. Minus pi to pi. Folded version is same. What is the DC value of this rectangle? Area of the rectangle pi by fundamental period 2 pi. DC value 1 by 2. After subtracting DC, what is the change in the graph? If I remove 1 by 2, the amplitude level of that signal becomes plus or minus half. The amplitude level of that signal becomes plus or minus half. That will appear like this. I am showing in the graph only the half wave. Just observe carefully, everyone, the screens are. Just observe carefully. Minus pi to pi segment I am taking very thick. Minus pi to pi segment. What we are doing in half waves are first amplitude scaling of past two-sided segment. You have to take amplitude scaling of past two-sided segment. Later on, this red signal left shifted by half period. Half period is pi. Later on, this red signal left shifted by half period means 100% this segment is retained. So even plus half wave. Which terms are possible? DC already exists. Cosine terms for odd harmonics only. Cosine terms for odd harmonics only. By direct observation, we felt even symmetry, sir. But after subtracting DC, we also felt it exhibits half-wave symmetry. So what is the advantage of removing DC value? Now you can understand. In the first example, that is sawtooth example, by removing DC, we felt it has odd symmetry by removing DC. In this example, by removing DC, what we felt? Half-wave symmetry. So when you subtract the DC, what is the advantage we are getting? Verification of symmetry becomes easy. Actually, I want to tell one point very clearly, sir. For which type of periodic functions you will have extra DC? Whenever the positive negative amplitudes are not same. Whenever positive negative amplitudes are not same, 100% DC exists. See the sawtooth signal? Here positive negative amplitudes are not same. So 100% DC is there. But next graph plus V minus V, no DC. Next graph plus V minus V, no DC. Next graph also plus V minus V, no DC. This graph again positive amplitude means 100% DC exists. Okay. Whenever the positive negative amplitudes are not same, 100% DC exists. See, sir, one segment is like this. For that, we have done amplitude scaling. That is like this. After that, that red signal left is shifted by half period. If you make left shift of half period, we are in a position to observe the signal from minus pi to minus pi by 2 or not. So it has 100% half wave symmetry. Whenever the positive negative amplitudes are not same, 100% DC exists. Whenever the positive negative amplitudes are not same, 100% DC exists. For any periodic signal, if positive negative amplitudes are not same, 100% DC exists. I'm moving to next slide. Now everyone should respond. Which is the correct option? Everyone should respond. Easy question. Yes, half wave symmetry means always odd harmonics only. If I solve a problem on that, then you will know how it contains only odd harmonics. I solved only one problem till now. What is the least spread of the signals are? 4. Rocket shape is reference for us. Rocket shape is reference for us. %, it is even symmetric. Of course, also half wave. Even plus no DC. Because positive negative amplitudes are same or not. As both halves are same, xt equals to x minus t condition. Even that, how it is obeying half wave? What we have to do for half wave? Amplitude scaling of first positive sided segment. Amplitude scaling. Then you try to shift that red signal left by half period. Half period is 2. Cosine terms for odd harmonics. Wantedly, I have given in all the options DC. No DC here. Because positive negative amplitudes are same. Above +2, below -2. Emotional fellows. Just now I stated, immediately I asked the question. If positive negative amplitudes are same, 100% DC will be 0, sir. If they are different, then only DC exists. For this M of t graph, above +2, below -2. From where you will get DC? There is no DC. It has even symmetry as well as half wave. With respect to y-axis, 100% even. 0 to 2 segment, you make amplitude scaling, that is this red signal. But what is half wave condition? We know half wave condition is what, sir? M of t must be equals to minus M of t plus or minus t by 2. So after taking this red signal, try to left shift by 2 seconds. So if you make left shift of 2 seconds, we are retaining this segment. So it also exhibits half wave. That red signal you left shift by 2 seconds. It means, what is the point to be observed, sir? What is the symmetry and which terms are existing? Even symmetry means DC cosine terms are existing. Odd symmetry means only sine terms are existing. Half wave, only odd harmonics. Even plus half wave means cosine terms for only odd harmonics. Odd plus half wave, sine terms for only odd harmonics. In all cases, you may have chance of getting extra DC also. In all cases, even for odd periodic function also, you may have extra DC. When it can have extra DC, if positive and negative amplitudes are not same, 100% DC exists. Whenever the positive negative amplitudes are not same for any periodic function, DC exists. We have even harmonics also, but no special significance. There is a statement, full wave rectified sine wave contains even harmonics. Tomorrow's class you will know it. Don't be emotional. Certain periodic functions will have only even harmonics. What is even harmonic? 2 omega naught, 4 omega naught, like that. The example for that is full wave rectified sine wave. Full wave rectified sine wave. This is the conclusion every fellow has to remember. Even periodic signal means which terms are possible? DC cosine. Odd periodic function means only sine. Half wave means only odd harmonics. Even plus half wave, cosine terms for odd harmonics. Odd plus half wave, sine terms for odd harmonics. I am giving a simple idea for you. Suppose I have taken a graph like this. I am speaking only about DC. Above 3, below -1 means positive DC or negative DC. Bachas, respond. Above +3 amplitude, below minus taken. Positive DC or negative DC? Positive. Same signal graph, suppose I have taken like this. Above 1, below -3. Positive DC or negative DC? Above +1, below -3 means positive DC or negative DC, sir? Negative DC. Suppose if I have taken above +1, below -1, then what is the DC? No DC. That point you recognize, bachas, irrespective of symmetry. Whenever the positive negative amplitudes are not same, 100% DC exists. Irrespective of symmetry, sir. Whenever the positive negative amplitudes are not same, 100% DC exists. Okay. These things you have to remember. This I have written only from table, nothing new I created, sir. From the table only. Wait for a while, everyone. Very funny models you'll get on this concept, sir. Okay, we are at 31 actually. Think of this question. Consider the periodic signal which is sum of cos and sine. What is the power that is lying in a specific frequency band 10 to 20 Hz? Normally, what is the power in the sinusoid directly? A cos or A sine function means what is the standard power answer, sir? A square by 2. What are the two frequencies present? 10 pi means first time frequency 5 Hz. 30 pi means second time frequency is 15 Hz. Where the power is asked, sir? Power in 10 to 20 Hz means only second frequency is within that range. Second frequency 4 square by 2 watts. First frequency is outside our range. That fellow is expecting power in a specific range 10 to 20. Only first frequency has that chance. Only first frequency. If it is asked for a total power in the problem, then you can take 58, 10 square by 2 plus 4 square by 2. 10 square by 2 plus 4 square by 2. But we want power in a specific range. Power in a specific range. Everyone think of the right-sided model and respond. Sine terms for odd harmonics are given. If you replace omega naught t equals to pi by 2, that addition is simplified as what? If we replace omega naught t equals to pi by 2, addition is simplified as what? Is the question, sir? Very good, Srikant. After substituting pi by 2, it becomes 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, like that, sir. Generally, everyone will think of, seriously, it is related to which standard formula. That way we'll think, which is not needed. Fourier series definition itself is approximation. Try to approximate the first 4 numbers. It is actually pi by 4, 3.14 by 4. 3.14 by 4 is 0.785. Addition of first 4 numbers is one of the option. Because the definition of Fourier series itself is, it is an approximation. Approximate the numbers. Of course, actually it is tan inverse x series, sir. Actually it is tan inverse x series. Tan inverse 1 pi by 4. Without by hearting that general solution, approximate first 4 numbers. I think after 8, 8, 10, every day some fellows will get loose motion, I think. Once 8 o'clock is over, emotions are over. Instead of by hearting this solution, sir, this is easy. Just add the first 4 numbers and choose one of the option, approximated. Because definition of Fourier series itself is, it is an approximation. Messa. I don't know, ma. Acha, college here. Those who are staying in college mess. Then why to join 5 to 9 batch? If that much urgency is there, no other option. Huh? It's okay. The things are going on like that. What we will do? Think of, sir, this model. Xt is a real valued function of a real variable with a time period capital T. It's a trigonometric Fourier series expansion contains no terms at certain frequencies. No terms means at that frequency coefficient amplitude is 0 and there are no sine terms also. Then that periodic function satisfies which of the given option. Very easy question. Every fellow should answer me. Very easy. The coefficient amplitude is 0 for certain frequencies. So it is 0 for indirectly even harmonics. It is 0 for even harmonics means only odd harmonics are present. That means with symmetries are only odd harmonics are present means half wave xt equals to minus x of t plus or minus. That is one point we extracted. No sine terms is indication that only cosine terms are possible means even. Even signal condition is xt equals to x of minus 2. Equate 1 and 2, you can feel option C. What overaction this fellow has done is, normal periodicity condition is what, sir? Xt equals to x of t plus t or not. There only he substituted evenness. Normal periodicity is x equals to x of t plus t. There only he substituted t plus minus t. Then you can feel third option. In the question statement only has given hints are amplitude 0 for even harmonics means odd harmonics possible. No sine terms means cosine terms. So that fellow is indirectly saying even plus half wave. Even plus half wave. This funny question every fellow can answer. What is the fundamental frequency of the composite signal? Multiple cosine functions are added. We want fundamental frequency. Simply take GCD. Take GCD and tell me the result. So simply take GCD, sir. 0.2, 0.25, 0.3. What is the GCD? Like n omega naught logic, first one is 4 into 0.05, 5 into 0.05, last one 6 into 0. Simply take GCD. you are unable to solve this way, multiply all frequencies by 100, sir. 20, 25, 30 means what is the common number? Multiply all frequencies by 100. 20, 25, 30 means what is common? 5 number. 5 divided by 100 is 0.05. If you are unable to take directly, multiply all frequencies by 100. 20, 25, 30 means 5 is the multiplier divided by 100. Think of this example. We want the average value of the periodic signal. Time period 6. What is the theoretical definition? Area of the signal over one period by time period. What is the area of this triangle and two rectangles are? Half into base into height. Rectangle 1 into 1, 1 into 3, 5 by 6. All these are competitive questions only, sir. Not for fun I am discussing. Area of the signal over one period by fundamental period. Very good. Most of you have responded. Take the area of triangle and two rectangles divided by fundamental period. Think of this problem. Some signal graph is given, asked for A naught. It is neatly obeying with symmetries are half wave because positive negative excursions are same. What is A naught? Above plus 1.5, below minus 1.5, positive negative excursions are same means what is A naught? 0. Think of this problem. A periodic rectangular signal has some waveform shown in figure. What is the fifth harmonic of its spectrum? What is the time period of the signal graph, sir? What is the time period? 4 milliseconds. Time axis is given in milliseconds. So F naught becomes 1 by T. That is 1 by 4 into 10 power minus 3, 250 hertz. So fifth harmonic means what? First calculate time period, 4 milliseconds. That will give us F naught. F naught is 1 by T. Fifth harmonic means 1250. Okay. Think of this. A periodic signal in a duration of one period is shown. Its Fourier series expansion includes. First of all, everyone tell me what is the time period of the signal graph? What is the time period of the signal graph that you tell me? How much, sir? I know 100% you will give wrong answer. Every fellow who typed. Study the question properly, yeah. Maybe you are in rosy mode. Huh? A periodic signal in a duration of 1 period is shown. Time period is 2 seconds only. Wanted, I have given shifted segment here. 10 fellows, they cannot stop their emotion. Fatafat. Huh? Actual time period is 2. Wanted, I have given shifted segments, sir. A periodic signal in a duration of 1 period is shown. So time period is 2 seconds only. Of course, for every 2 seconds, it is repeating its pattern. Above 3, below -1 means positive DC. If you subtract 1 from it, the amplitude becomes plus or minus 2. After subtracting -1 amplitude from that, of course, this exhibits which symmetries are odd plus half wave. Already we have done that type of graph. So sign terms for odd harmonics only. We are having DC, but it is neglected in the problem, sir. We are having DC, but it is neglected in the problem. Actually, he has to mention DC also. He has neglected it. Time period is 2 seconds only. Study the question properly. A periodic signal in a duration of 1 period is shown. So time period is 2 seconds, not 5 seconds. After removing DC, we can feel odd plus half wave. So sign terms for odd harmonics. The RMS value of the periodic waveform. RMS value is square root of power. How to get power in periodic signals are 1 by t integral 0 to t mod xt square This is a regular model in gate paper, sir. Either from networks or signals. Regular model. But already we have predefined formulas of this. Integral 0 to t mod xt square dt. Just recollect everyone. Rectangular part energy. How much we have written? A square t. Triangular part energy means A square t by 3. That relation you use. Apply that relation. So 1 by t. This triangular segment energy, how much we can write, sir? Minus 6a whole square width is t by 2 by 3 plus rectangular part energy, what you can write? Rectangular part 6a whole square into t by 2. Take energy in the triangle and rectangle because of our predefined relations. 6a whole square t by 2 by 3, 6a whole square into t by, that is simplified as 24a square. RMS value is square root of that 2 root 6a. This is a regular habituated model in gate paper, sir. Regular model. All problems we solved maximum by which concept? Omega naught converted to n omega naught. All problems take single frequency, generate multiple frequencies. Some more examples are there under trigonometric series. We'll continue tomorrow. After completion of that, we'll start exponential form. That's all for today. Good night.